Good day, everyone. Welcome back to the channel. In this video, we will talk about package managements. When navigating the Linux community, we encounter diverse opinions on the best Linux distribution, often delving into trivial debates like desktop aesthetics. Yet, the crux of a distribution's quality lies in its packaging system and the robustness of its support network. Linux's support landscape is ever evolving, with frequent updates and new versions across top tier distributions every 6 months and continuous program updates daily. Effective package management tools become essential in navigating this dynamic software environment.
Unlock the world of Daisy Ninja puzzle books, where excitement meets brainpower. Dive into the mind-bending labyrinths of Maze Mastermind. Conquer the Sudoku challenges in Sudoku Ultimate. Uncover hidden words in Word Search Wizard, and decode mysteries in Word Spy Adventures. Whether you're soaring above the clouds or speeding down the tracks, turn your downtime into brain-boosting fun. Perfect for all ages, these books guarantee hours of entertainment. Daisy Ninja Puzzle Books, your passport to endless excitement on the go. New release each month.
Package management, the method for installing and maintaining software, has significantly evolved. Today, most users fulfill their software needs by installing packages from their Linux distributor, a far cry from the early days of downloading and compiling source code for installation. While compiling code isn't obsolete and remains a fascinating aspect of Linux, pre-compiled packages offer swifter and more user-friendly installation process. This chapter delve into command line tools for package management, while major distributions provide sophisticated graphical programs for system maintenance. Understanding command line tools is crucial as they tackle tasks that may be challenging or impossible through their graphical counterpart. Now let's talk about packaging systems. Various distributions employ distinct packaging systems, typically rendering a package designed for one distribution incompatible with another. Broadly, distributions aligned with one or two package technologies, the Debian.deb system or the Red Hat.rpm system, while exceptions like Gen 2, Slackware, and Foresight exists. The majority adhere to either of these two foundational systems. Lately, new packages such as the Snap package and the Flatpak packages are also becoming popular. Packaging system and the distributions. Debian style is .deb, which is present on Debian, Ubuntu, Sandros, and Linespire. We are using Pop OS for the tutorial that is based on Ubuntu, which is further based on Debian. Okay, so we'll be talking about .deb packages. Red Hat style.rpm, Fedora, CentOS, Red Hat Enterprise Linux, OpenSUSE, Mandriva, PC Linux OS, etc. How a package system works. In the proprietary software domain, the typical software distribution involves purchasing installation media like an install disk and employing an installation wizard to add a new application to the system. Certainly, Linux follows a different approach. Almost all Linux software is sourced from the internet. The majority is supplied by the distribution vendor in the shape of package files, while the rest exists in source code form. Allowing for manual installation, installing software by compiling source code will be covered in a subsequent chapter. All right, package files. The fundamental components within packaging system is the package file, a compressed assembly of files constituting a software package. It can encompass multiple programs and support data files. Alongside the installation files, a package file contains metadata detailing the package and its contents. Moreover, many packages feature pre- and post-installation scripts executing configuration tasks before and after installation. These package files are crafted by a figure known as a package maintainer, typically associated, though not always, with the distribution vendor. The package maintainer acquires the software in its source code form from the upstream provider. The program's author compiles it and generates the package metadata along with any essential installation scripts. Often, Modifications are made to the original source code by the package maintainer to enhance the program's compatibility with other components of the Linux distribution. Repositories. While a few software projects opt for handling their own packaging and distribution, the majority of packages are crafted by distribution vendors and trusted third parties. These packages are housed in central repositories curated for each distribution, often containing thousands of packages, each meticulously tailored and maintained. A distribution typically oversees multiple repositories catering to distinct stages of software development life cycle. For instance, there's commonly a testing repository housing freshly built packages intended for the intrepid users who scout for bugs prior to their general release. Additionally, a development repository harbors work in progress packages slated for inclusion in the distribution's forthcoming major release. Moreover, distributions might feature related third party repositories. These repositories serve to provide software that, due to legal constraints like patents or DRM, anti circumvention issues, cannot be included within the distribution itself. A well known instance involved encrypted DVD support, which lacks legality in the United States. These third party repositories operate in regions exempt from software patents and anti circumvention laws. They typically remain wholly independent of the distribution they support, necessitating users manual inclusion of their configuration files within the package management system to access them. Dependencies. Software programs rarely operate in isolation. They often depend on other software components to accomplish their tasks. Everyday functions like input output are managed by routines shared among multiple programs. These routines reside in the shared libraries, offering crucial services to multiple programs. When a package necessitates a shared resource like a shared library, it's deemed to have a dependency. Contemporary package management systems universally offer some form of dependency resolution to guarantee that upon installing a package, all its dependencies are also installed. High and low level package tools. Package management systems typically comprise two categories of tools: low level tools, managing tasks like installing and removing package files, and high level tools responsible for metadata searching and dependency resolution. In this chapter, we'll explore the tools offered within Debian style systems such as Ubuntu and similar distributions, as well as those utilized in recent Red Hat products. While all Red Hat style distributions rely on the same low level program, the RPM package, they employ different high level tools. In our discussion, we'll focus on high level program Yum utilized by Fedora, but I'll show you the examples on Debian. Other Red Hat style distributions provide high level tools possessing similar functionalities. So Debian style low level packages are called DPKG, and high level tools are called apt-get or aptitude. Fedora, Red Hat, Enterprise Linux, and CentOS have RPM as the low level tools and Yum as high level tools. Okay. Common package management tasks. Numerous operations are executable using command line package management tools, and we'll delve into the most prevalent ones. It's worth noting that the low level tools also facilitate the creation of package files, an aspect beyond the scope of this book. Throughout the following discussion, the term package name denotes the specific name of a package, distinct from package file, which refers to the file housing the package. Finding a package in a repository. Utilizing high-level tools for repository metadata search enables locating a package by its name or description. In Debian, you'll say apt-get update or apt-cache search string. In Red Hat, you would say yum search string. For instance, to query a yum repository for the Emacs text editor, you can employ this command, which is yum search Emacs. Okay. Installing a package from a repository. High level tools facilitate the retrieval and installation of a package from a repository, ensuring complete dependency resolution. In Debian, it's apt-get update or apt-get install package name. On Red Hat, it's yum install package name. Example, to install an Emacs text editor from an apt repository, you would say apt-get update, then semicolon apt-get install Emacs. Okay, so generally you'll have to use the sudo command, which means super user do, which we learned in a couple of chapters ago. So you would say sudo apt-get install Emacs. Okay, once you press the enter key, it'll ask you for your password. You enter your password, press the enter key, and it will ask you to confirm your installation. You'll say yes, press enter. And once you do that, the installation process will start. First, it is going to download all the required files, which will take about a couple of minutes, depending on the speed of your internet connection and the size of the package. Once done, it'll be back to your prompt and the app should be installed. Okay, pretty easy, right? So now let's talk about installing a package from a package file. Should a package file be acquired from a non-repository source, it can be installed directly, albeit without dependency resolution, using a low-level tool. So on Debian, you would say dpkg -- install package file. In Red Hat, you'll say rpm-i package file. For instance, if the package file for the Red Hat system for the Emacs app is this, and which has been obtained from a source outside a repository, it would be installed in the following manner, right? So we have a package that has been already downloaded. It's the Opera browser. To install this on your Ubuntu-based system, you would simply say sudo apt install -- then the name of the package, and then the enter key, and it'll start installing. Each installation process is different. So over here, it might prompt you for certain things, but it seems like the app was installed. And clear the terminal. To confirm, you can just open your app browser, and once you look for the file Opera, the app Opera, it has been installed on the system. Okay. Note, because this method utilizes the low-level RPM program for installation, it doesn't execute dependency resolution. If RPM detects any missing dependency, it will terminate with an error. Okay, but we installed using the apt protocol. It did not cause us any errors. Removing a package, you have the option to uninstall packages using either the high-level or low-level tools. Below, the high-level tools are presented. So on Debian, you would say apt-get remove, then the name of the package. On Red Hat, you would say yum erase package name. So to uninstall Emacs package from a Debian system, use the following command. Let's do that. We'll say apt-get remove Emacs. Press enter. And now, as you can see, it is giving us a permission error. That is because we don't have the permission to run this command. So to bypass that, you would use the sudo command. And when you press the enter key, it'll tell you that the operation will free up this much space. You'll say yes, you'll press enter, and Emacs is now removed. Okay. Updating packages from a repository. One of the most frequent package management tasks involve keeping the system updated with the latest packages. High-level tools can execute this crucial task in a single step. On Debian, you would say apt-get update and apt-get upgrade. On Red Hat systems, you would say yum update. So let's check it out. You can say sudo. Remember to add sudo, and you'll say apt-get update semicolon apt-get upgrade. Now it will go through all the apps installed on your system, update all of them, and if any of them require an upgrade to a newer version, it will do so. Once you press the enter key, it'll run all the commands. And as you can see, we did not employ the sudo command for the upgrade command. To bypass that, you will say sudo apt-get upgrade, and once you press the enter key, it'll run the update command again. Then it'll also run the upgrade command. You say yes, and all the packages have now been updated and upgraded. Okay, you can clear the terminal. Upgrading a package from a package file. Should an updated version of a package be acquired from a source outside a repository, it can be installed there by replacing the previous version. On Debian, you will say dpkg -- install package file. On Red Hat, you would say rpm -u, then the name of the package file. If these commands don't work, don't forget to use the sudo command. If you want to update your Emacs program on your Red Hat system, you would employ the following command. Okay. Unlike RPN, dpkg lacks a dedicated option for differentiating between upgrading and installing a package. Listing installed packages. These commands can be used to display a list of all the packages installed on the system. On Debian, you would say dpkg --list, and it'll show you all the packages that are installed within your system. Okay, to get out, you just say q, and you're out of the list. Okay, on Red Hat, you would say rpm-qa. Determining if a package is installed, these low-level tools can be used to display whether a specified package is installed. On Debian, you would say dpkg-status and the name of the package. Let's try it out. We'll say dpkg-status, and we will say Opera, which we installed a few moments ago. It says Opera is not installed, but let's call it Opera-stable. And now it is telling us that it has been installed. The version 105.0.4970.48 is installed. Okay, you can check the status of the Emacs, which we uninstalled. We'll say dpkg-status Emacs, and the Emacs is not installed and no information is available. This is because we uninstalled Emacs just a few minutes ago. Okay. Displaying info about an installed package. When you're aware of the installed package name, the following command can be utilized to showcase a description of the package. So you would say on Debian apt-cache show package name. It's apt-cache show. Then the name of the package, which in our case would be Opera-stable. And this is the information that we were provided with the command. Okay, on Red Hat, you would say yum info package_name. Example to see the description of the Emacs package on a Debian system. Let's try this out as well. We'll say Emacs, and this is the status of the program. Okay, finding which package installed a file. To identify the package accountable for the installation of a specific file, you can utilize the following command. On Debian, you would say dpkg-search and then the name of the file. On Red Hat, you would say rpm-qf, then the name of the file. To see what package installed /user/bin/vim file on a Red Hat system, you would employ the following command. All right, so let's summarize the chapter. In the upcoming chapters, we'll delve into various programs spanning diverse application domains. Although many of these programs are typically part of a default installation, we might require additional packages if certain necessary programs aren't already on our system. Thanks to our enhanced grasp and appreciation of package management, installing and managing the necessary programs shouldn't pose any challenges. These are some of the myths related to the Linux system. If you are interested, do go through this little document attached at the end of the chapter, and all the chapter notes are added to the description. Do follow all the commands in the chapter. Do install a few packages and uninstall a few packages. And in the meantime, have a good one, and I'll see you in the next video. Take care. Bye-bye.